Hey there, guys. Welcome to our next lecture. As you guys know, we just started talking about the cell membrane and its structure on Friday, learning about how there's not just lipids in there, but there are actually proteins that play a really big component into this. So today, we're actually going to be looking at the transport component of the proteins so that you guys can see what their importance is in this cell membrane. So this is just a quick recap from last time. Um, First, we're going to be looking at what the purpose of a cell membrane is. And you guys should have already seen this, and it should already kind of be in your head to the point where you might even be able to answer these before I even write them. Okay. Remember that a cell membrane separates the inside contents of a cell from anything that's outside. Okay. The other thing, and many of you guys get this wrong, you put proteins for this, okay? It's not proteins. It's the cell membrane that actually protects the cell, okay? And it acts in a very similar fashion as our skin does for our body, okay? This is the part where the proteins start coming in, right? It's the proteins that allow for communication between cells. And it's these proteins that also regulate the transport of materials into and out of the cell. Okay. And then, so just going into these protein notes a little bit more, you guys have already seen this a little bit. Remember, they serve three major functions. Number one, they serve as identity markers. They allow us to recognize what cells are self cells, our cells, versus foreign cells. And this is really important in that immune response. When you guys answered those deeper questions in the jogger last Wednesday, there were some of those that really kind of challenged you in making sure that you understood that it's these identity markers that differentiate our cells from bacterial cells. The other thing that they do is they act as receptors, right, for all of these different signaling molecules that are sent to the cell, and these allow for the communication aspect between cells. Okay. And then last but not least, they're able to transport molecules across the membrane. And it's right here, okay, so we're going to be talking, this is our focus for today, okay? And then lastly, I just wanted to make sure you guys understood what the semi-permeable membranes were. And again, it lets certain things through. Okay. And what exactly can pass through directly? Remember, this is small nonpolar molecules. And if you guys forgot what nonpolar means, this is not charged. Okay? So that should all be recap from what we have done previously in this unit. And this is starting some new material. Okay? So it's important that you guys know that every cell exists in a liquid environment. Okay? Molecules are constantly moving around. If you guys think of any water, salt water, maybe if you're at the beach and there's an ocean and there's seaweed in it, everything in that ocean water is constantly moving around. Nothing is stagnant like it is in a solid. Okay. This term that's coming up is something you're going to be hearing a lot of. So particles easily move, but only with their concentration gradient. Okay, so particles easily move with their concentration gradient, and if they move with the concentration gradient, they can do so without using any energy. You guys will understand this in a minute once we actually apply it. Think about sugar in coffee. So if you guys look at this example I have over here, you'll notice on the left, we have this big clump of sugar. Now you guys know when you drink coffee or maybe you put sugar in tea, that clump of sugar doesn't stay like that. What happens is that the sugar, it spreads everywhere throughout the solution, right? It's moving from an area of high concentration, right, where it's down here all together. Okay, there's high concentration. And what it's doing is that it's actually moving to areas of low concentration. And CONC is going to be my abbreviation for concentration. Okay, so we're going from these high area and we're going to all of these different low areas that don't have sugar. And what this gives us, right, is that after you put the sugar in, you'll notice that we have an equal amount of sugar everywhere. Right? Equal amount throughout. This should look familiar to you guys, okay? And that's exactly what's going on, is that the sugar moves with its concentration gradient, okay? So, a concentration gradient is present whenever there is a high concentration of molecules in one area and a low concentration in a nearby area, okay? Just like this coffee. We had a high concentration and it moved to all of these lower concentration areas until the concentration was even, all right? A great example of this is actually a dam. Now, I don't know how many of you guys have actually seen dams, okay? But what dams do is that they're these really big walls and they hold water, okay? So we have all of our water on this right side. And what do you guys think would happen if this dam was to break, right? If this dam breaks here. What do you think? Well, is the water just going to stay really, really high up here on the right side? No, right? What's going to happen is that the water is going to move, right, to all of these areas that don't have water. It's going to move from a high concentration right, way over here to on the left where we have a low water concentration. Okay? And again, that's only if that dam breaks that you're going to see that happen. But it's very similar to the sugar where you're moving from where there's a lot of something to where there's little or none of something. Okay? So the next idea that we have to get in our head is, what do we call this? Well, this process we actually call diffusion. You guys may have heard of this before in middle school. Okay? And it's the process of molecules moving with their concentration gradient, okay, from high areas of concentration to low areas. That's what we consider to be with, okay? If this said against, something's going against the concentration gradient, it goes from a low conc area to a high concentration area. And it requires energy because that's just not the way that anything in this universe moves. All right, and again, I just want to remind you guys that this is only when we say against the concentration gradient, okay? Note that diffusion is with the concentration gradient. So, it's not actually going to use any energy, okay? So passive transport is the exact same thing as diffusion, okay? They're one of the same. And our formal definition, because I know you guys like to have these that are concrete, right? Diffusion is the movement of molecules across the cell membrane okay, without using energy. We're soon going to learn about different ways to actually move molecules across the cell membrane, but they're going to require energy. Diffusion does not, okay? Um, what I want you guys to know is what we were talking about that coffee above, right? You'd put the sugar into it, and I said, right, that it's going to be, the sugar's going to move from its high concentration to its low concentration environment, and then it's going to get to a point where the concentration is equal throughout, okay? When there's an equal number of molecules, right, throughout a solution or across a cell membrane, we say that equilibrium has been reached. And there's only one L in this, okay? Equilibrium. This is when we have an equal concentration throughout a solution. However, this is a really important point because this gets forgotten a lot. Even when equilibrium has been reached, molecules still move across the cell membrane, okay? That means that diffusion is still occurring. And down here is actually a great picture of it. So as you can see here on the left, right, we have all of these molecules on the outside. And what's going to happen is they're going to go from a high concentration, right? It's our high conc area. Here's our low concentration area down here. And so what you're going to see is that there's going to be a bunch of molecules that end up coming across, right? All these guys are going to come across. However, at this point, to our right, we're going to see that at some point, okay, equilibrium is reached. And remember that that means that the concentration is equal inside and outside the cell. Right? But note that here we still have diffusion occurring. All right, and this is the big deal, is remember, because it's in a liquid, right? No matter what, it's like the ocean. These aren't going to stay stagnant. These molecules are still going to move across, and equilibrium is going to be maintained, okay? Whew, so I know this is a lot coming at you guys again, but I feel like if you guys try and use your common sense when you're thinking about all of this, it's going to be able to help you a lot in understanding what's going on. So what I ask is that you guys now go about filling out vocab and then complete your your partner assignment actually at the end of class. If you have any questions, please raise your hand. I have tons and tons of more examples, and we're going to be doing a lab on this stuff really soon that I think you're going to enjoy. All right. Thanks again for watching, guys. Enjoy class.